electromagnetic field that produces an identical polarity to the approaching magnet. The magnet is, this is the magnet approaching the coil, okay? And the magnetic field produces a north pole that is resisting the magnet's approach to the coil, and at top dead center, the potential difference falls to 0, and then the current changes direction. And as the rotor magnet is moving away, now the coil is producing a south pole and resisting the magnet's departure. Resistance on approach, resistance on departure, okay? So if we look at the load current delay in a ReGenX generator coil that's wound on the same core as the conventional coil, and we look at everything in the exact same time domain with the exact same purely resistive load with the same resistive value, we will see that the ReGenX generator coil, okay, the load current is delayed by between 45 degrees to as much as actually 90 degrees or more than 90 degrees. What does this mean practically in the operation of a ReGenX generator coil? Well, what it means is that from this point to this point, in the lower magnitude of the current, load current sine wave, we're incurring regenerative braking. But once the magnet is past top dead center, the ReGenX generator coil is producing its delayed load current with the magnet that is on the other side of the coil's core. And so it's producing a north pole repelling magnetic field on a magnet that is moving away. The load current sine wave for the conventional coil, okay, establishes the relative position of the rotor magnet to the coil's core. So it's approaching, it's top dead center. The magnet is top dead center. Now it's moving away. The ReGenX generator coil is producing a north pole repelling magnetic field when the rotor magnet is moving away. This is where the ReGenX generator coil produces its load current to the load, to the battery, and regenerative acceleration. And that's basically it. If you understand inductive reactance, and you understand capacitive reactance, and you understand how frequency affects them both, and you understand total impedance, and you understand purely resistive loads and sine waves and that sort of thing, then none of this will come as any shock to you, and it will make sense to some of you, others it will not. At any rate, that's basically it. Thank you for taking the time to watch this video. Cheers.